Additional access line was installed on the router machine. This small access line use small stepper motor, and it has the benefits of lighter in weight. If a large linear actuator is used, there will be a heavier loadings on the machine, on this settle. Now we go to the stepper drivers for this stepper motor. We cannot use the original stepper drivers in the machine. In this machine, I have the 4X stepper driver inside. Since it is of voltage of 13.4 volt, and this little motor, according to the spec, it uses 12 volt. If you attempt to connect the wire to the controller stepper drivers, a large current flows through this small motor will generate a lot of heat, and these large currents will also damage the motors, because these high currents will demagnetize the magnets inside it. So don't attempt to do so. Instead, I use a separated stepper motor driver here. I built these drivers a couple years ago, and it's not a new one, and it used the bridge driver or power driver of L296. And also the motor controller is L297. And I use the motor supply here, and it is set to 12 volt. This little stepper motor is 2-phase and 1.8 degrees per step, and its spec is 12 volt, and it comes with 6 wire, but I only use 4 wire. There is 1, 2, 3, 4. These 2 center tapped wire is not used, so I use 4 wire, and this stepper driver is 4 wire bipolar stepper driver. Another type of stepper driver use 6 wire. It calls the unipolar stepper driver. And you can see I I now connect to the 4-axis, to the 4x terminal. So I hit this, it will go up. And down. It goes to how to setting up the parameters in the Mark III. The original CNC routers have the controller of this model. I think it's the most earlier versions, and it said is 2.1 ampere and step angle precision 1x step, and is 1600 step per revolution. So with this data, I calculate. So we want to calculate how many steps to go to 1 millimeter, and the least screw have the pitch. I mean the original CNC router machine. This screw pitch is 6 millimeter. So 1600 divided by 6. That means 266 steps will advance the screw nut 1 millimeter. So we take down this data and we go to motor tuning. We fill up 266 steps in this box. We fill up this value for x, y, z. And for the new z line, it had 1.8 degrees per step. So we calculated it again. In one revolution, 316 degrees divided by 1.8 degree. So there are 200 divisions, 200 steps per revolution. But this little linear actuator has smaller screw pitch. It is 1 millimeter. So it needs to take 200 steps to advance the screw bushing 1 millimeter. So we directly put down. Actually, we directly put down 200 in here. That will be fine. And we can see that even though we in this small linear actuator we have the stepper driver having the micro stepping, that is, we just full step, and we still have the 200 steps per 1 millimeter. Since it has little pitch 1 millimeter, and in compare with the x-axis and y-axis, it has 266. So the resolution is almost the same, just just almost the same. One is 266 and here is 200. Now let's talk more about the detail. Actually, I here just a brief discussion of the stepper driver construction, and our computer have the program of Mark III, and it will generate the pulse change with a certain frequency. This is the pulse, and this pulse will come to the outer controller box. Inside there is the stepper motor drivers, and these drivers will provide the step pulse to the stepper motor. And we just said that my new small stepper driver spec have this, and my DIY stepper driver have the selection of full step and half step. And let's see the constructions of a stepper motor. This is the magnet north and south poles. It's just a simplified diagrams just to show the theories, and also the coil. This coil represent this coil, and this is two phase, so there are two set of coil. So how this magnet can be turned, rotate, when we provide a 0 voltage on this coil and certain voltage V on this coil, there is magnetic force to turn this poles to 19 degrees, and it is the full step. When one pulse come in and give this a voltage V, then it will rotate by, let's say, 19 degrees. But in another mode is half step. There is a selection in the driver. When we set to half step, now let's look this diagram. If we don't provide full voltage on this coil, let's say half voltage V, then this rotor, magnetic rotor, will not completely turn to 19 degrees. It just 45 degrees. And this full pulse is actuated by a full voltage V. The driver can have the circuits. For the first pulse, it will give only half voltage to it, and the second pulse it will give the full voltage to it. So first pulse will go to this direction, and the second pulse it will go to 19 degrees. And furthermore, for example, in the CNC-STEP controller, it has micro-stepping. It will subdivide a full voltage to more divisions, so it can turn to 1016 steps per revolution. This is a brief explanation of how the stepper driver works. And let's go back to our Mark III setting. And here, if we go to half this, if full step, we put 200 here. If we select the half stepping in our driver, we put 400 step here. And that's what now I'm setting in my driver. Here there is a selection. This one for setting full step and half step. And that's for these tutorials. Thank you for your watching.